the original intensity of this pixel is Z. Z is the original intensity of this pixel. And let us say S is the final intensity that we want, final value of intensity. And let us say, suppose just an example. Let us say I say that S is equal to 255 minus Z. Suppose S equal to 255 minus Z. So if suppose there is such an equation which I specify, Z is original intensity, S is the changed intensity, final intensity. So what will happen if I apply this law to the intensity of a pixel? This point, look at this point, the value of Z is 0. All along this line, the value of Z is 0. So I'm considering a point where Z is 0. So when Z is 0, that means what will be S? S will be equal to 255. That is this point. And when your Z is 255, then your S is 0. According to this equation. Followed it? Am I right? When Z is 255, S is having the value 0. So if I plot a graph between this side I am taking S and this side I am taking Z. So have you understood these 2 points? Have you understood this point and this point? And this is the equation of a straight line. Y is equal to mx plus c. Y is equal to mx plus c is the equation of a straight line. Y is equal to mx plus c. This is the equation of a straight line where m is called the slope. This is called the slope. So if you compare S is equal to 255 minus Z, then slope is equal to -1. So this particular line is having a slope equal to -1. So I think you understand. So this is why I am doing it, so that if you tell me the intensity of a pixel, suppose if this intensity of a pixel is 200, so I can go to this point, suppose this point is 200, and straight away from this graph, I can read what will be the final intensity according to this law. And if you recognize this law, S is equal to 255 minus Z, this is the complementing of image, complementing of law, complementing, because white pixels will become black and black pixels will become white when you apply this law. Z का Z0 है, ओरिजिनली यानी कि ब्लैक पिक्सल है, तो फाइनली व्हाइट बन गया, और ओरिजिनली व्हाइट था तो फाइनली ब्लैक बन गया. Rest of the pixel will have accordingly the gray value. So this is the operation on a single pixel. Now, second type of operation which is done on images is called neighborhood operation. Just a minute. Second type of operation that is performed on images is called neighborhood operation. In case of neighborhood operation, we are changing the value of intensity of a single pixel only. Okay. Suppose this is the image. It is shown here. This is the image. I want to change the intensity of this pixel. But now the intensity of this pixel will not be changed only based on the previous value of this intensity, but to change the intensity of this pixel, we will consider many pixels around this. So we will consider this whole area, the pixel lying in this portion, we will consider the intensity of all those pixels, and based on that, we will change the intensity of this center pixel. So whatever area you consider in this process, that is called neighborhood. So here, this neighborhood is, this is the neighborhood. Neighborhood. So this neighborhood is m by n pixel. M by n pixel means there are a total small m pixel from here to here, and there are a total small n pixel in the horizontal direction, which are being considered to change the intensity of this fellow, middle fellow. That is called neighborhood operation. So for example, suppose I take an example. Suppose I want to change the intensity of this pixel. And for that purpose, what I am doing is, whatever is the neighborhood I have considered, let us say there is a pixel, this is the pixel. And around, suppose if I make this area slightly bigger, this is the center pixel. Let us say I divide this into this. This I have projected here. This thing I am explaining on the right hand side. Suppose there is a center pixel whose coordinates are x, y. The coordinates of this fellow is x, y. And I am considering one pixel above. Very difficult, bhai. बहुत difficult है. Every time, no, you come so late. ठीक है ना? So this particular pixel is having the value, the coordinate x, y. The whole rhythm goes. So suppose this is the, again I am making it to explain you what is neighborhood operation. I am considering this particular pixel, and coordinates of this pixel is x, y. Okay. For this purpose, I am considering a neighborhood. And that neighborhood is consisting of one row above this, one row of pixels below this, one column of pixel on the left, and one column of pixels on the right with respect to the center pixel. So that means in this case, this pixel, this pixel, this. There are 9 pixels which are being considered to change the intensity of the center pixel, mind you. So suppose what we are doing is, we are saying that you take the average value of the pixel of these 9. So that means whatever is the intensity of this pixel, whatever is this, all 9 intensities I am adding up and dividing by 9. This is the operation being done, which is written here. Averaging of the intensities of neighborhood pixels. So what we are doing, 1/9 and summation intensity of neighborhood pixels. Okay, 1/9 summation of intensities of neighborhood pixels. So 9 values will get added up and divided by 9. Whatever that number comes, that will be assigned, this will be assigned to the center pixel. So this is the new value of new intensity value of center pixel. Are you getting me? So that new value has been assigned based on neighborhood intensities. For example, this is the original image. You can see this is the original image. This is the original image. And we have applied this law. That means the averaging. I have taken the neighborhood here. This neighborhood can be taken of any size you like. Here it is called 3 by 3 neighborhood. In this example which I gave you, this is 3 by 3 neighborhood. You can take 5 by 5 neighborhood also. Like said, this is the center pixel. Around this, I am taking 2 rows above this, 2 rows below this. Similarly, 2 columns on the left and 2 columns on the right. So this is the center pixel, and I am adding up the intensity of 25 pixels here, 25 pixels, and divide by 25. So 1 upon 25. I am doing summation of all intensities. So that is being done here. So whatever neighborhood you take, you start from the top left of the image, and this is the neighborhood you have taken. You have changed the intensity of the center pixel of this neighborhood. Then you shift your neighborhood 1 to the right, your grid to the right. Again, you change the intensity of the center pixel. Keep on doing it. The whole row will be covered this way. And all center pixel will be undergoing a change of intensity. Then, when the row is completed, you shift your grid 1 pixel below. This is the grid now. Shall I should have changed this thing. Just a minute. 1 minute और रुको. जहाँ इतना डिले किया ही है तुम लोगों ने. मुझे ये कलर चूज कर लेना चाहिए. That is better. So after that, I take this neighborhood. Okay, and again I change the center pixel intensity based on these 9 values, let us say. And then again I shift this to here, and then again I shift this to here. Are you understanding what I am saying? So this way, the center pixels of each row and each column, they will undergo a change. They will acquire a new intensity. And that is averaging of the intensity of the neighborhood pixels. So this is the averaged image. After averaging, this is the image, averaged image. देखो तो blur हो गई है. This has become blurred. I think you can understand why it has become blurred. Sharpness of the image is gone. Okay? Because every pixel, wherever it is, every pixel has undergone a change and that is the average of the neighborhood pixels. So now it doesn't have it is a combination of all those intensities. That's why the image becomes blurred when you take this type of averaging. This is called low pass filtering of the image. Okay, whenever this operation is called the average filter. Average filter, and it is a low pass filter. So therefore, I think now you understand what is a low pass filter. Low pass filter. This equation. And because of this low pass filtering, the image becomes blurred. That is the, sort of characteristics of low pass filtering. But do not think, please, do not think that if the image is blurred, then image is deteriorated. No. The quality of the image has not gone down. Although it is not looking good to our eyes, but don't think that it is useless thing. There are processes you will come to know later, like segmentation. Segmentation. Okay, where in order to distinguish between two objects, this type of averaging is very useful. Okay, in the segmentation, we will decipher one object from other object. Okay, in order to take out the object of our interest from that image. I told you what is segmentation. ठीक है ना? तो वहां पर you will see that the averaging of the image is an asset. This is a method of segmentation. Just a minute. हाँ सुबह. हाँ. अच्छा. हाँ हाँ बताया था. हाँ हाँ. ओके. अच्छा. हाँ बिल्कुल. तुझे अच्छा तुझे जाना होगा क्योंकि मैं तो जा भी नहीं पाऊंगा. अगर जो वो देखकर तैयार है तो मे भी, क्योंकि देख ऐसा होता है ना, पहले से हम लोग तैयार नहीं है ना इसके लिए. मतलब अभी जैसे बताया ना तूने, तो मेरी जैसे क्लास ऑन है इस टाइम, तो हो सकता है कि संजीव की कोई मीटिंग हो तो मैं फोन करूं क्या उसको, क्या या तू कर ले, की बात है. हाँ वो तो एक ही बात है. हाँ मेरे से बात हो गई है. अगर वो जा सके तो चल ठीक है, नहीं तो तू अकेला चला जा. चल ऐसा है कि वो हो जाएगा. तू आज की डेट या तो टलवा दे या कुछ करवा दे. हाँ फिर देख लेंगे. नहीं अभी तो मत दे यार. अभी मत दे. एक बार हम ईसी में देख वो कर ले. अभी ईसी की मीटिंग बहुत जल्दी रखने वाला हूँ, है ना. फिर ईसी में कर लेंगे एक बार. हाँ ठीक है. हाँ 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 वो तेरा वो, लेकिन वो रह गया. मैं ले लूंगा. चलो बाद में वो फोटो कॉपी कर रहा था ना, जो तूने रिपोर्ट भेजी थी, वो रिपोर्ट मेरे पास है ही नहीं. मतलब अब वो फोटो कॉपी मशीन में रह गई. हाँ हाँ मैं ले लूंगा. चिंता न कर, मैं उससे मंगा लूंगा. हाँ 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 ठीक है ठीक है ठीक है. हाँ हाँ, सेंटर से लिए हैं, सेंटर से लिए। ठीक है ठीक है ठीक है ठीक है, डन डन डन। हाँ 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 हाँ, मैं नहीं, मैं ऑफिशियली ऑफिशियल करूंगा उसको। हाँ हाँ यार, हाँ यार, हाँ। ओके, चल ठीक है, कर यार। सॉरी सॉरी फॉर, बीच बीच में होता रहता है। एक्चुअली आई एम चेयरमैन ऑफ दिस IET, आई थिंक यू मस्ट हैव हर्ड द नेम, Institute, this Electronics and Telecommunication Engineers, Institution of Electronics and Telecommunication Engineers, IETE. So I am chairman of that also. So lot many phones come because of that. So what I was saying is that low pass filtering is very useful in segmentation, and this is one of the I mean important methods to segment the object from a large image. Okay. हाँ वो, हाँ कोई नहीं बता। हाँ करा दो, साइन करा दे। So now this is pure mathematics, which I don't want to tell you, and I don't want to drag you into mathematics unnecessarily. Rather, you should get the feel of image processing. But you can certainly understand one thing, that suppose there is an image like here, this is the image of alphabet T. This is the image of an alphabet T. So this image can be enlarged or it may be shrink. There may be a zooming or shrinkage of this image. Then this image can be rotated around, about this axis, which is perpendicular to the plane of this slide. So we are rotating in this direction, this image. Okay, this image can be translated, that means shifted in Cartesian coordinate system. And this was the origin previously, this was the origin. Now the image has, the origin has shifted here. I mean from here, the origin is shifted here. So with respect to origin, the image is at a different place as compared to this. Can you compare these two? And you will say that this image is a translated image of this. Similarly, you can rotate the image about this axis. This is the axis of rotation in this case. Here the axis of rotation was perpendicular to the plane, that means Z axis. This is called shearing. These last two are called shearing of image. So what I mean is that you can define certain matrices which are called affine matrix. Affine matrices. So this is the affine matrix for scaling. This is the affine matrix for translation. This is for translation. This is for rotation. This is for shearing, and this is also for shearing about this axis. By defining these matrices, what we can do, we can find out the new coordinates of a pixel if we know the old coordinates of a pixel. Are you getting me? What I mean is, suppose on this image there is a pixel xy. The coordinates of this pixel was xy. Let us say 2, 3. For example, just let us say 2, 3. Then suppose I want to zoom this image. So therefore, when you zoom the image, definitely this pixel will not remain at 2, 3. This pixel will acquire a new position. समझ रहे हो ना बात को? वही पोजीशन तो नहीं रहेगी ना, पोजीशन will change. So what will be the new coordinates of this same point? ठीक है ना? So new coordinates, they can be, suppose they are VW, So they can be calculated by multiplying the old coordinates, that means 2, 3, 1. This 1 we write from our side, that is all due to mathematical reasons. And then whatever is this matrix, that matrix you can write here. And by this amount of zooming will be known to you, so these things are known to you. How much you want to zoom along x-axis, how much magnification you want along y-axis. Suppose I want to zoom it by 2 in both the directions. So if I want to zoom it by 2, so that means the cx will also be 2 and cy will also be 2. So that means the matrix will become 2, 0, 0, 0, 2, 0 and 0, 0, 1. And I know the old coordinates of a point, suppose. So that way I will be able to calculate the new coordinate, new value of x coordinate and new value of y coordinate. Okay, by this multiply, just matrix multiplication, as you do, you will get the new coordinates. So that way, this exercise can be done for all the points which were lying on the image, and therefore I can find the new coordinates of all the points, and therefore I can find out the new position of the pixels of the image. So that is the idea to zoom the image. This program, this multiplication, when you zoom the image, when you give a zoom command in MATLAB, in fact, in the background, this multiplication procedure is going on. ठीक है ना? आपने तो एक command दे दी. Okay, you have given one command. But due to that command, a program runs in the background, and that program calculates this sort of multiplication, and it gives the new coordinates, and those new coordinates are displayed on the monitor, and you are able to see the zoomed image. Similarly, for other things, when you want to rotate, you can see the rotated image, but during rotation, in fact, old coordinates get multiplied by this matrix, and you get the new coordinates of the points of the image. So that is the way that new images are obtained. Geometrical transformations are done. So, baki, don't mug up these matrices. Just you have come to know what is being done in the background by computer program, and this is geometrical image processing. Okay, this is nothing. Okay, see, this is what is